Okay, so go ahead and get those done. Make sure you read the comic. It's amazingly funny. Dealing with a kite. That's how it relates to the math. I know. Okay, let's go ahead and start talking about some of these. I realize that not everyone might or maybe completely finished, but in terms of Theorem 916, can I get a volunteer to read that one?
I got you.
Go ahead, Nick. What do you got?
Base angles of an isosceles trapezoid are congruent.
Good. Base angles of an isosceles trapezoid are congruent. So I guess it's first important to actually define what a trapezoid is, right? So trapezoid, if you recall what a trapezoid is when you have two sets of parallel sides. All right? Or excuse me, one set of parallel sides. My goodness. There we go. One set of parallel sides. That's your trapezoid. Now, an isosceles trapezoid is changed up just a bit, right? An isosceles trapezoid, you have your set of parallel sides, but you also have these legs are congruent in an isosceles trapezoid. And that would mean our base angles are also congruent. All right? So if we're looking at our note sheet, and by the way, that's what Nick had just read there, right? That's Theorem 916. If we're looking at our note sheet and adding that to our note sheet, go back to this. We're dealing with an isosceles trapezoid. Are all sides congruent?
No.
What opposite side's congruent?
Sure. No. On one of them is.
On one side.
Yeah, on one side, but not all, right?
Yeah.
So let's keep going. Opposite sides parallel?
No.
Well, one set, right? Opposite angles congruent?
Yes. No.
What do you think? Here. Opposite, so that one and that one?
No.
Nope. Okay. Well, actually, I can't do that. But, okay, so we have opposite angles congruent. Nope. All right angles?
No.
Diagonals bisect
Yep.
Yes.
in a trapezoid?
Yeah.
You sure? No. They're not. They don't bisect each other. Nope. And so if I sketch them in here, and it's not like we're measuring it, but if I sketch those diagonals in, okay, they're not going to bisect each other. All right? Diagonals congruent.
Yeah.
Yes, they are. Okay, diagonals perpendicular.
Kite.
No.
No. Diagonals bisect opposite angles. Nope. Base angles congruent. Yes. Only one diagonal bisects opposite angles. Nope. Only one set of opposite angles congruent.
No.
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 Nope. All right, let's move on to the next theorem. Okay, the diagonals of isosceles trapezoids are congruent. We got that one. Okay, let's move on to kite. Hey, a kite? There's our kite. What do I know about a kite? Go ahead, Gracie.
Like the two adjacent sides are congruent, like the top two are, and then the bottom two are congruent.
Good work. Okay. All right. Is this angle and this angle congruent?
No.
No. Hey, if your eyes aren't up here, make sure they're up here. Be paying attention. How about this angle and this angle? Yes, these are congruent. Okay? So we have one set of angles congruent. One of our theorems talked about the diagonals of a kite. What happens to the diagonals of a kite?
Reflex. Oh, no.
Yeah, they're perpendicular. And I think, JJ, did you bring that up yesterday?
Yeah.
Yeah, they're perpendicular to each other. Do they bisect each other?
No.
No. All right. Does this diagonal bisect this angle?
Yes.
These two angles?
No.
They don't. Nope. How about this diagonal bisect this angle?
Yes.
You can actually notice this. This side's congruent to itself using reflexive. Right? And this is a right angle. You have hypotenuse leg right here, right? So that means this angle is congruent to itself by hypotenuse leg CPCTC.
Oh.
So yep, that's congruent. Same thing can happen over here. This one is congruent to itself. Okay, so one diagonal bisects. However you want to mark that. This diagonal does not bisect that angle though.
Does the top? Is that marking showing the top bisecting?
Yeah. So let's remark that. That little marking, that's another way to show they're congruent. I use that because I use the one mark there. Okay? So, that being said, in terms of kite, all sides congruent?
No.
Nope. How about opposite sides congruent?
No.
Nope. Opposite sides parallel?
No.
No, in fact, none of these apply until we get down to where?
Diagonals perpendicular.
Diagonals perpendicular. There are two others that we can check here. This one, only one diagonal bisects opposite angles, and one set of opposite angles congruent. All right, so this is your stuff now for, this is your note page, all the stuff we've covered, right, for 9.3 and 9.4. That's a lot of stuff. Okay? Any questions there? Okay, so for those of you cranking away on your assignment here, start working on number 1 now. Okay? Find the measures of angle 1 and 2. Most of you are pretty good about this. This is isosceles triangle, and it was asked a while ago, why are there triangles on our assignment? Notice if I extend this side down, and I extend this side down, and I draw a base right here, what's that shape that I just drew on the bottom? Yeah, that's our isosceles trapezoid. And this angle is congruent to this one by? Yeah, good job. Corresponding angles, right? All right, that's why we have the isosceles triangle. Okay, we're just cutting off the cone.
Is it right to have a
No, it's not a right triangle, it's isosceles.
No. Is it right to have your answer like for number 1, let's say, I'm just gonna make this up here, 36.3?
It could be, yeah.
Is that right for angles?
It could be, yeah.
Okay.
You'd like to put it in fraction form.
Oh, you want it in fraction?
So Eli, all triangles add up to what? 180. 180 minus 27 is?
153.
Good. Hopefully we're not using our calculators for that. Maybe we should if I put 7 there. Okay, 153. And how are we going to find angle 1 and 2?
Divide by 2.
Good. 153 cut in half. That gives us one of those angles. And that is? 76 and a half. Good. All right. Angle 1 and angle 2, 76 and a half. So each one. And if you want to put 0.5 since it terminates, that's okay. Terminate's a cool word. So, all right. Everyone tell your neighbor how you're going to do number 3. Come up with an answer there. What do all the angles of a trapezoid add up to? 360. It's quadrilateral, right? Okay. And as JJ asked, he said, hey, is this angle and this angle, are they congruent if these are congruent? The answer is yes, because the reality is, if I turn this, this is my base, right? So those of you not paying attention right now, you missed the conceptual piece, which just means you're learning rules. That makes it tougher. This is your base. If I turn it this way, that's my base, which means this angle and this angle are congruent. Okay, so each of your bases, this is congruent to that, that's congruent to that, so that makes this 62 degrees. And 62 and 62 is what?
124.
124, and we're subtracting that from? 360. Okay? 360 minus 100 is 260 minus 224, or minus 24? 236. And what do we do with that 236?
Divided by 2.
Divide it in half.
Which is 118.
118. Good job. 118 degrees. Okay, questions?
No.
All right, moving right along. Number 5. Take a look at 5. Hey, that's the shape that I just drew.
Wow.
Except for theirs looks a little different. A little more professional. Okay, what do we know about angle 1 and 2? What are those things called? JJ? Corresponding, yeah. So they're congruent, right? Corresponding angles are congruent. Come up with your measure for 2, and then you can figure out 1. Good, so the measure of angle 2, Mitch, what do you got?
I have 74.5.
74.5, so 180 minus 31, right? That gives us 149. And then you cut that in half? All right. Get 74.5. Okay, measure of angle 1 is? Also 74.5. I've already said they're congruent. Okay, everyone rate themselves 1 to 5 right now. Kind of moving through it fairly fast. Okay, very good. Any questions? Eli? Oh, all right. Here we go. Moving back. Number 9. Take a look at number 9. I want you to work with your partner to fill out that proof, please.
So when it says diagonals are congruent,
All right, number 1. QR is congruent to ST. Well, if we go through our givens, we've got that up there. Given, we're trying to prove that QS is congruent to RT here.
shouldn't they state that it's an isosceles trapezoid to be able to state that RT2 is congruent
That's
to
what it says.
Yeah, it does say, they should state that in their statements. Yeah, they didn't state this. They should state that it's given the isosceles trapezoid. Okay? But we are trying to prove, remember, that this is congruent to that. Okay? And so angle RQT, remember doing these types of problems just a while back?
Yeah.
Okay? So we have RQT, this angle right here, congruent to this angle right here. How do we know that?
All base angles are congruent.
Good. So 2 different ways we can say it. We can say all base angles are congruent. Base angles of an isosceles trapezoid are congruent. Some would say by definition of an isosceles trapezoid. I'm going to put base angles
Yeah.
of an isosceles trapezoid or trap are congruent. Because I got to say isosceles and trap. Okay? QT, oh man, QT is congruent to QT, yeah. That's pretty cute. Okay? Yeah, it'd actually be TQ, I guess, if you're flipping the triangles by reflexive property. In triangle RQT, so this one here is congruent to this triangle here by, yeah, so we have QT to QT, so we have now angle and a side and an angle, or excuse me, a side, an angle, and a side. Yeah, side, angle, side, so side, angle, side.
It's got some sass.
Got some sass. How many got that far? Well done, eh? Okay, and then we got this one congruent to that one. SQ, or QS, since that's what they gave us, congruent to RT by CPCTC. And then make sure you end it. Zippity-doo-dah.
Can't you just put a smiley face for your name?
You could. That'd be happy.
But I'm just too cool. I just put my initials.
Yeah. Okay, questions? All right, moving along. Why don't you try number 10, please? Work with your groupies. This one's a tougher one, little twofer.
What did you get?
So, a couple of you have an answer. Andrew, what'd you get? You want to volunteer it?
I got 12.
You got 12. Anyone else get 12? Nice. Anyone else want a second or come up with a different answer? Yes? 12. That's what he said.
I didn't hear her.
I said it.
Oh.
Eli? 8.3. Anyone else?
Oh.
13.9. Okay. Well, Andrew, how'd you get 12?
I did the base 33
Uh-huh.
minus the top base 23,
Uh-huh.
and I divided that by 2, and then I did the Pythagorean theorem. I did 13
Whoa, hold on.
Why did you divide by
So
two?
33 minus 23. So when you're taking that off pictorially, let's give everyone a picture of that. When I take that 23 off of the 33, I'm left with 10. And that 10 splits up that base down here. This base now is 23,
So that'd be 5.
and this is 5, and this is 5. Andrew, is that where you're going?
Yeah.
Very well done. Okay, so you divided it by 2. So 10 divided by 2. Okay. Now what?
Did 13 squared minus
Okay,
Square root that.
good. So what are you using there?
Pythagorean theorem.
Yeah, so he's working with this triangle right here using the Pythagorean theorem. He's saying a squared plus b squared, bc squared. Okay, and this is c. Remember our longest side is c, so that's the 13 squared over here. A squared I'm going to call 5, square it, and we're looking for, we'll call that b. That b squared as well. Okay? 5 squared is 25. 25 plus b squared equals 169. Subtract 25, b squared, b 44. And Andrew says b equals 12. We take the root of both sides, right? Square root, square root. Andrew gets 12. Andrew, you are correct, Amundo, and all the minions that agreed with Andrew are also correct. Well done. Yes?
Couldn't you just, because the way I did it, as I remember, that was a Pythagorean triple.
Yeah, Pythagorean triple. Well done. How many remember Pythagorean triples? What is the most popular Pythagorean triple?
3, 4, 5.
3, 4, 5. Is that what you're going to say?
Yeah.
No.
I was going to say 3, 4, 5. Yeah, 3, 4, 5. Most popular. Everyone wants to be like 3, 4, 5. Okay? Very good. Nice job, Andrew. Any questions on it? Your assignment. Can I see your paper?
No.
Let's go with the mixed. Good thinking. All right. Yeah. Tomorrow we're reviewing 9-4. Okay? So get a good start on the mix tonight. If you don't quite finish it all, we'll grade it at the end of class tomorrow. Okay? So it doesn't mean go home and don't do anything. It means don't spend any more than a half hour on math tonight. Okay? Get going on. You should be able to get a chunk of it done, though.
We already did the first problem.
What?
It's that one, but in different words. Different numbers.
Ridiculous, what I'm thinking. Hey, we recorded the lesson today, so if everyone wants to say hi, say your voice loud.
Hello.
Aw.